Benzene and unsaturated compounds such as alkenes both are having double bonds in common. But yet, benzene is exceptionally stable when compared with unsaturated compounds. Do you know why? The secret lies in its aromatic character and something called Huckel's rule. Hi, I am Dr. Swathi, your organic chemistry coach. In this video, I will simplify these concepts clearly so that you will never forget them. Now let's jump into the topic. So what is aromaticity? So aromatic compounds are cyclic, planar, and they are fully conjugated molecules, and they show exceptional stability due to delocalization of electrons. So the best example is benzene. So in order to call any compound as aromatic compound, it should meet with certain criteria, such as the first important condition is the molecule should be cyclic in nature. That means the molecule should exist in the form of a cyclic ring structure. The molecule should be planar. That means all atoms which are present in this cyclic ring, they should lie in one plane. And third important condition is the molecule should have complete conjugate. That means the p orbitals which are part of those connecting carbon atoms must overlap with each other. And finally, it should satisfy Huckel's rule. So what is this Huckel's rule? A compound should have 4n plus 2 number of pi electrons in its cyclic cloud. Now let us deep dive into this Huckel's rule. What is this Huckel's rule and what is its importance? Huckel's rule is proposed by Eric Huckel. This Huckel rule mainly explains the aromaticity of the molecules. So as per Huckel's rule, a molecule should have a continuous cyclic cloud with conjugation. That means as per this rule, a molecule should be cyclic in nature and it should contain a conjugated system. That means it should have delocalization of pi electrons distributed throughout the ring system. And the cyclic cloud should be continuous in nature. So that is the first criteria. And this pi cloud should contain a total of 4n plus 2 number of pi electrons in it, where n can be 1, 2, 3 and so on. Now, when a compound is meeting with these two criteria, then it is said to be aromatic as per Huckel's rule. Now, let us consider few examples. So, the prototype aromatic compound is benzene. Now, let's see how Huckel's rule is obeyed in case of benzene. So, the first important criteria in Huckel's rule is the compound is said to be aromatic when it has continuous cyclic cloud of delocalization of electrons. Now, if you see, benzene is a cyclic molecule, and here in the resonance structure of benzene, we have seen that this delocalization of electrons is continuous. It is above and as well as below the plane. For the calculation of this number of pi electrons, I have written the first Kekulé structure. Okay, so if you count the number of pi electrons in this, the molecule is having 3 double bonds. So 3 double bonds means each double bond composed of 2 pi electrons. So overall 3 double bonds are present means benzene overall it consists of 6 pi electrons. Now when you equalize 4n plus 2 equals to 6, then we will get n equals to 1. So whenever we get n equals to 1, 2, 3 and so on, that means the compound is obeying Huckel's rule. Okay, so thus benzene is said to be aromatic in nature because it obeys Huckel's rule. Now let us consider a few more examples. So this is naphthalene structure. So naphthalene here, 2 benzenoid rings will be fused ortho to each other. Okay, so in this structure, if you see, the total number of double bonds are 5. So one of the benzene ring is having 3 double bonds and the other benzenoid ring system is having the other 2 double bonds. So overall it contains 5 double bonds. Each double bond accounts for 2 pi electrons. So overall 5 2s are 10 pi electrons are present. So in order to call any compound as aromatic, the cyclic cloud should have 4n plus 2 number of pi electrons. We know that the pi electrons present in naphthalene are 10. Now let us try to equalize it to 4n plus 2. So 4n plus 2 equals to 10, where 4n becomes 8. Thus finally n becomes 2. Okay, so here also we are getting a proper number. So that means even naphthalene is also obeying Huckel's rule. Thus, it is said to be aromatic in nature. So this is the structure of anthracene where 3 benzenoid rings are fused linear to each other. So the total number of double bonds, if you see, first ring is having 3 double bonds, the second ring is 2 double bonds and the third ring is 2 double bonds. So overall total number of double bonds are 7 double bonds. So each double bond accounts for 2 pi electrons. So 7 2s are 14 electrons are present overall in this anthracene molecule. Now let us see whether this molecule obeys Huckel's rule or not. For that what we have to do, 4n plus 2 equals to the total number of pi electrons present in this molecule. So that is 14. Then obviously we will end up with n equals to 3. Okay, that means even anthracene molecule also obeys Huckel's rule, and that is why it is aromatic in nature. So all these three molecules, benzene, naphthalene and anthracene, okay, they obeys Huckel's rule. Now if you see in these three examples, you can observe in one molecule we got n equals to 1, in another we got n equals to 2, and another molecule, that is anthracene, we got n equals to 3. Can you make out what is the meaning of this n now in this rule? I hope you guessed it right. It is nothing but the number of rings. So where you got n equals to 1, in case of benzene you got n equals to 1, where the total number of cyclic systems are 1 in case of benzene. When it comes to naphthalene, naphthalene consists of 2 cyclic rings. Okay, there we got n equals to 3. And in case of anthracene, where the total number of ring systems are 3, so there we got n equals to 3. So here n refers to the number of ring systems present in the given aromatic compound. Now that you have learned about Huckel's rule and aromaticity, so test your knowledge and understanding about this particular topic with these examples. Okay, so here 3 structures are given. Comment which of these molecules are aromatic in nature. So next time when you see a cyclic molecule, quickly check whether it is obeying Huckel's rule or not. Based on that, you can make out whether the given compound is an aromatic compound or not. So if you found this video is helpful, then hit like, subscribe my channel and share it with your classmates. Don't miss my detailed video on orbital structure and resonance structure of benzene, which is already available on my channel. Thanks for watching and stay tuned to my next videos.